to visit with you for a few moments this morning, talking about some of our experience in trying to manage invasive annual grasses here in Utah. We have plenty of invasive annual grass species that we deal with here, including the common brome species, downy and Japanese brome. In lesser quantities, we have infestations of medusa head and ventonata. We actually have a couple of species we typically think of as agronomic species, including feral rye and jointed goatgrass, that we see more commonly out in our wildlands and specifically foothill spaces. And then in our state, as we move further south, we actually get into some of the more desert species, including red brome. As we think about research that's been done over the years, my first opportunity to work with invasive annual grasses was in 1992, helping a fellow graduate student clip biomass samples in medusa head plots. And amazingly, at that time, the two products they were looking at for invasive annual grass control were glyphosate and metsulfuron. And then through the years, as these new products have come online, I've had the opportunity to work with imazapic, rimsulfuron, aminopyrrolid, and then in 2015 with Indaziflam. So I want to cover about three kind of broad areas of kind of lessons learned and some of the concepts behind them. Not very data heavy, but hopefully you get an idea of some of the work that we've done here. And the first is to talk about the idea that outcomes of invasive annual grass management are really dependent on complex interactions between the plant community that we're treating, the treatments that we choose and apply, and the environmental conditions, both including the conditions at the site and the rainfall and things that happen later on. Ideally, in an invasive annual grass management situation, we want to see this like we saw at Josie's Ranch at Dinosaur National Monument, where in the chart on the left, we see down at the bottom as downy brome cover is decreased by treatments, we get a nice increase in desirable grass cover. And that's kind of what we'd like to see. And that is not always what happens. So just kind of want to put this into context that the outcome from our treatments is really dependent on the beginning conditions of the site. What species are there? Which grass species are we managing? How long has it been there? As well as what desirable species might still remain at the site, and are they in high enough densities to recover once treatment is applied? And then the herbicides we choose have a big impact, including are they effective at controlling the grass? How long do they last? And are they selective? And some of that selectivity is really tied to when we apply them, the rates we're applying them at, and even what adjuvants we might be using. And then I think it's really critical just to understand that the weather and environmental conditions are the main driver, even once we apply these herbicides, and can have a large impact on what the outcome is or what the change in that plant community might be, either for the positive or for the negative. Treatment doesn't always bring about positive change. And I just want to show an example of where kind of the environmental conditions really impact herbicide effectiveness. In southern Utah, we can achieve annual grass control with about half the imazapic rate that we can compared to the northern Utah areas. And so just that change in environment has a huge impact on the effectiveness of the herbicides that we're using. I want to show the impact of environment on annual grass cover. So these are plots that show downy brome cover in the yellow line and perennial grass cover in the green line in untreated plots at two locations within Dinosaur National Monument. And they just show that according to the rainfall conditions shown at the bottom in inches between September and July of each year, how the downy brome pressure changes in untreated plots. And 2012 was actually so dry that there was very little downy brome. Hard to imagine that it's too dry for downy brome. But you can see the perennial grasses tend to respond not quite as dramatically as those annual grasses do. If we compare that to plots where we applied a single application of imazapic in the fall of 2010, what we see is that in 2011, we drive that downy brome cover down close to zero. But then as moisture returns to those sites, we see that the annual brome, the downy brome cover returns kind of to pre-treatment levels. So no real lasting effects, just temporary effects, mostly based on the activity of Mazipic and its short longevity. If we compare that to 4 different applications of glyphosate, Mazipic, another application of glyphosate, and then a final application of glyphosate plus aminopyrrolid, what we can see that in the Josie Ranch location, even with 4 treatments, the downy brome cover really kind of returns close to pre-treatment levels. Whereas at Echo Park, once we've applied all of those treatments, what we see is that the perennial grasses are starting to recover along the way. And in 2015, they actually have about double the starting cover, and the annual grass, the downy brome, is being suppressed by that cover. And so here the issue is that the control with one treatment isn't long enough to actually allow the perennials to recover. To further illustrate how site impacts outcomes as well as herbicide selection, on the left we have the same herbicide applied at 2 different locations or starting points, if you will. And in the top, you can see a plant community that's non-existent or no desirable species. And in the bottom, we can see where there was a good residual, a desirable perennial community, which was able to respond once the downy brome or Medusa head was removed in these different sites. In the middle charts, we have, again, these are pictures, the next 2 sets from Dinosaur. We have the same site with different herbicides. And so in one of the systems where a Mazipic was applied, we can see in the top middle slide that the warm season perennial grasses were injured versus where we used the aminopyrrolid, there was not injury. So a dramatic difference in the response of these species. And then the same 2 treatments, but applied at the Echo Park location, where we can see that the Mazipic treatment did not control poverty weed, and so we were left with a mix of broadleaf and grasses on those plots, versus where we incorporated aminopyrrolid, it controlled the poverty weed and we're left with a solid stand of the grasses. And either one of these outcomes might be desirable depending on your management objectives, but the herbicide selection makes a difference in that final outcome and condition of the site. The second thing that I've learned is it's better to protect than to restore plant communities. And we've done a lot of research looking at trying to reseed highly degraded sites. We've evaluated different herbicide programs, treatments before, after, and even during planting. We've done a lot of work trying to evaluate species tolerance to different herbicides with and without things like activated carbon as a safener. And out of the established sites, or out of the sites where we've done fall seedings, we've only had establishment and persistence in one location. That was in 2018. And if you look to the top right, you'll see that 2018 had 4 inches above the 30-year average for precipitation, compared to the year before where it was a complete failure, which had 4 inches below the 30-year average. So we're talking about an 8-inch difference in precipitation. It's hard to deal with when we don't control that. So our conclusion is that we must control invasive annual grasses prior to and during establishment. We know that if we don't control them, that they will prevent the seedlings from establishing, but also that seedling establishment and persistence is really moisture driven. The third thing I want to talk about is multi-year suppression of invasive annual grasses with Indaziflam generally increases desirable plant cover and biomass while preserving plant diversity on the locations where we've tested it. And whether we're talking about downy brome on the left, vetinata in the middle, or Medusa head on the right, what we've seen is that where we have residual plant communities, perennial plant communities, and we treat with Indaziflam, Indaziflam is providing long enough control that we see really positive responses of those perennial species. We've even taken that to locations that have high plant diversity and native plant diversity with fairly low cover of downy brome. And what we've seen again is very good safety to the desirable species. Often we're able to measure an increase in plant cover as we remove those annual grasses. And again, we've not really not seen any impact to plant diversity on these sites. So if we kind of put this all together, I like this flow chart. I think is it critical that we think about when we set out to put treatments on the ground, that we make an evaluation of whether or not there's a remnant desirable plant community. And if there is, I think we can go straight to a product like Indaziflam that can provide that long term, maybe even up to 4 or 5 years of control of the annual grasses and allow that remnant community to rebound and to reestablish. If not, if there's not a remnant desirable community, we need to think more about our restoration approach and select maybe shorter residual herbicides that help us control the brome or the annual grass while we establish desirable species. And once they're established, then maybe revisit this idea of a treatment to protect that investment of seeding that we've put into that site. So where have we come with invasive annual grass management? Well, we have more tools than ever before to manage invasive annual grasses, and having a product like Indaziflam that provides multiple year control just really has changed some of the opportunities that we have. I think careful consideration of management objectives, site conditions, and treatment options are critical to achieve positive outcomes. Strategic treatments can preserve important plant communities and also can provide defense against wildfire, especially maybe at the urban wildland interface. And we're kind of excited because some of the treatments that have shown such good control of invasive annual grasses are also showing promise for control of other invasive species. Again, being able to manage the seed bank more effectively and more long term. And so with that, I'd just like to recognize financial support we've had for our treatments over time and try to answer any questions if there's time.
Great. Thank you, Corey. We do have time for a question or two. The first one I have for you is, how do you consider bare ground when thinking about invasive annuals versus perennial grass dominance? It seems that especially in Utah, in the drier part of the biome, regaining that occupied bare ground with bare soil on the surface, but perennial roots underground may be important.
Yeah, I'm not sure I fully grasp that, but it is in a lot of our lot of our habitats in Utah. The natural condition would be a lot of bare ground space. We're so limited for moisture, and so I think it is critical that we reestablish that so those plants have the resources that they need. It's often a little scary. We're not used to seeing clump bunch grasses with not anything growing in between, but that's kind of how they were in the past. So, but we're able to achieve that. How long without high density of grasses? That's another question. I think that becomes harder to maintain complete bare ground versus allowing a perennial grass cover that has a high density to kind of recapture the available space.
Mm-hmm. Our next question is have you ever seen any recovery over time on your site where you determined there was no residual plant community?
That's a great question. And in general, we see pretty quick response if there is a native plant community. And in the really tough ones, we don't see that recovery over time. I would say, though, that I would expect recovery over time if there's enough plants there that once they're released from competition, they're able to flower and produce seed. I think in the long term, we can maybe see a resurgence of native species as the herbicide disappears from the site and more seed production occurs. So, that would be a hopeful thing, more seed recruitment, because those plants aren't growing under that intense competition from the annual grasses.
Mm-hmm. Nice. All right. One final question is, did you see any suppression of native annual grasses if when you applied Indaziflam?
Yeah, that's a really important question as well. We have not specifically seen that in our settings. Some of our perennial grasses are not native grasses. From historically, there's been like Western wheatgrass and other things that have been put in. But we have not seen dramatic changes in that. Most of the instances where we've seen decreases in our perennial grasses is where we missed the timing of a glyphosate application and we're too
Mhm.
early, so that those grasses were still actively growing. I would say that if there's been any trends towards that, it's been on very coarse soils, maybe boulder filled covered sites. And so I, with Indaziflam, I think, the coarser the texture of the soil, the more possibility that you might get movement that could injure roots. But in our instances, we have not seen those negative effects.
Great. All right. Well, thank you so much for your time today. We're going to move on to our next speaker. We are going to hear from Morgan Roach, who is with the USGS, and we're going to hear a little bit about her research that she's been conducting. Go ahead, Morgan.
All right, how is it looking?
Perfect.
Great. Hi, everybody. I'm Morgan Roach. I'm a biologist at the USGS Fort Collins Science Center in Colorado. Yeah, thanks, Corey, for such a great setup for my talk. And I'm going to be focusing specifically on Indaziflam applications. We did a systematic review of field-based studies. But first, I wanted to thank our funders, the U.S. Geological Survey and the Bureau of Land Management, as well as our research partners. So invasive annual grasses, are present across Western rangelands. And then, historically, managers have relied on strategies such as targeted grazing or like some of these short-acting herbicides to reduce invasive annual grasses' impact. And while both of these strategies do have their advantages, their effects are pretty short-lived and require pretty frequent retreatment to continue reducing invasive annual grass cover. And I don't need to tell all of you, but this is very time and economically costly strategy. We were working with folks at BLM, requested kind of trying to understand herbicides with the longer term action in Indaziflam, and come up with kind of a better understanding of what conditions make an application consistently successful, to help them plan their herbicide treatments across kind of large landscapes. So why Indaziflam? It's a pre-emergent herbicide that works by preventing root elongation during seed germination, and it can stay active in the soil for multiple years, so super promising. And then specifically, since annual vegetation requires recruitment from seed each year for population persistence, in contrast to the native, sagebrush, most of the sagebrush system are dominated by perennial species. That annual invasive grass species life history strategy makes them particularly vulnerable to Indaziflam's mode of action. So in order to start answering these questions, we undertook a systematic review to describe the conditions and application strategies that promote reductions in invasive annual grass cover and positive changes to native plant communities following Indaziflam treatment. So these included kind of three themes: the pre-treatment vegetation community, application timing and rates, and treatment combinations. So we searched a variety of databases for literature using a series of keywords, and found a total of 36 sources that met our criteria. Treatment sites from these 36 studies were pretty broad across the sagebrush biome. There are some notable holes in eastern Montana and the Dakotas, as well as in the southern part of the range. And then there were 12 studies that included additional treatments such as seeding, prescribed burning, and then almost all of the treatments were monitored for multiple years, which is super important, with a median of 3 years of monitoring, but one study went up to 8 years of post-treatment monitoring. So here's the meat. I'm gonna start sharing the effects of Invasiflam on invasive annual grass species, and then I'll move to the effects on native species. So throughout the studies that we reviewed, Indaziflam had strong multi-year suppression of a variety of invasive annual species, including cheatgrass, medusa head, ventonata, and other brome species and some annual mustards. And this occurred for sometimes up to 8 years, with frequent reduction to frequent reduction to less than 10% cover, which is quite impressive. We saw similar success across levels of invasion, although some of those heavily invaded sites, since they just started off at such a high cover, failed to reach low cover following treatment. We found that first year control was often better if indaziflam was applied pre-emergence, but both pre and post-emergence application, there was little difference after that first year on long-term indaziflam performance on invasive annual grass. And then all tested rates, application rates, reduced invasive annual grass cover biomass, but those moderate to higher rates tended to provide longer lasting control and greater reductions in cover. And then lastly, indaziflam and imazapic in combination often outperformed indaziflam alone in that first year, but after that first year, indaziflam alone performed about equal or even sometimes better than the combination. So moving on to the effects of indaziflam on native species. Native species responses we saw were a little bit more variable. Perennial grasses frequently benefited from invasive annual grass control with indaziflam, but perennial forbs had some mixed responses. Sometimes they were positive, sometimes neutral, and sometimes a negative response, like non-target effects. But for annual forbs, since their life history affords them kind of a similar vulnerability to indaziflam's mode of action, we saw pretty consistent negative effects of indaziflam on annual forbs. And then, as expected, given indaziflam's effects on germination, seeding after indaziflam treatments was typically unsuccessful. There was a little bit of evidence that seed germination could be more successful when planting below indaziflam's zone of action, so it's like below 2 to 3 centimeters below the soil surface. But this will only be possible for species that can tolerate those lower seeding depths, and it's still not great success. So there were mixed responses to indaziflam treatments in different invasion intensities. So sites where perennial grasses were suppressed by invasive annual grasses seemed more likely to be released after indaziflam treatments, but that response was often neutral. Application rates or different application rates didn't seem to affect perennial grass response, but the annual forb density was less negatively affected when application rates were lower. And then lastly, the combination of indaziflam and imazapic seemed to have greater benefits for native perennial species than indaziflam alone in the short term, but those effects were often short-lived. So, that bump only lasted that first year. So, on the other hand, the combination of those two herbicides typically had worse outcomes for annual forbs than either indaziflam alone or just control treatments. All right, so before kind of bringing this all together, I wanted to talk a little bit about the kind of caveats of this study. So we only saw successful reported indaziflam treatments, which might not be super realistic and could be due to a bias in publication of treatments that were successful. So one way that some future work could kind of close this gap would be to work with practitioners who are doing tests or trials across large landscapes. That way, those failed treatments can still be included without that risk of publication bias if they were to happen. And then secondly, although we had hoped to assess how different climatic conditions were affecting indaziflam outcomes, the reporting in studies was super inconsistent, and so we were actually unable to assess those patterns. So if you're out there doing indaziflam research, reporting of the weather conditions and climatic conditions in a way that would be helpful for a meta-analysis or lit review would be really valuable to answering that question. And then lastly, there were surprisingly few reported secondary invasions, although we know that there's anecdotal examples of this happening. But because there were no reports of that in our suite of research studies that we were evaluating, we were unable to assess the likelihood of this outcome. So kind of overall, Indaziflam seems to be a pretty powerful tool for controlling invasive annual grasses, but its use does require careful site selection and consideration of trade-offs. So we found that Indaziflam treatments often suppress invasive annual grasses and support perennial species recovery, but it does come with risks to annual species and to seed bank persistence. So, for example, strategies such as choosing the lowest application rate that shows acceptable reductions in invasive annual grasses could limit the negative effects to native herbaceous species, native annual species. And then lastly, the risks of Indaziflam treatments will need to be balanced with the risks of failing to mitigate invasive annual grasses. So, for example, the risk of extirpating annual forbs, it may be worth the trade-off of reducing fine fuel contiguity or supporting perennial grasses. So to kind of bring this all together, we've been thinking about these trade-offs along this axis, this triangular axis. So sites with low invasive cover, these places on the left-hand side of the triangle, low invasive cover, low wildfire probability, and a substantial native annual component might be more vulnerable to non-target effects of Indaziflam and might not receive much benefit from the treatment. If the invasive grass component is quite small, it may not actually be suppressing perennial species or increasing wildfire risk. But then on the other side of the spectrum, on the right-hand side, lower right side, the Indaziflam treatments in heavily invaded sites could result in significant reductions in invasive annual grass cover, but without that existing established perennial component, the outcome may be bare soil. So if your goal is that, or to reduce fine fuels for wildfire, prevention of wildfire spread, that might be an acceptable outcome. But for restoration-related goals, some other treatment options are probably more appropriate in these conditions. And then lastly, the greatest return on investment might be in these sites that are kind of in between. So they have a strong perennial vegetation component. They may have moderate to high invasion of wildfire probability. But these places may have lower risk to native vegetation, they may have risks to native vegetation from the direct effects of annual grass invasion and also indirectly from wildfire. And those risks might outweigh the potential non-target effects from Indaziflam. So I'm happy to take any other questions, but please visit our webpage for updates. All this work is going to end up there eventually. So yeah, thank you.
Thank you, Morgan. I did post in the chat if people would like to learn a little bit more about her project. We have a nice web link to the USGS page specifically on it. We have time for about maybe a question or two. So starting out is, how do you define perennial grass recovery? Increased density or increased existing plant size? How would density increase with an active herbicide in the soil?
So in this study, we were going off of the whatever the authors of those research papers were going with. So, but they mostly were increases in cover, increases in density, so plant size, and positive changes in diversity. And so for the talk, I kind of combined them all into one thing, just like positive responses. But yeah, we did see, and yeah, the paper will have the actual breakdown of those three components. But yeah, we did see positive responses for all of those in various studies. Yeah.
Perfect. All right. What's the recovery potential on those native forbs negatively affected by Indaziflam? Is there research that compares the size of that effect to the negative effect of invasive annual grasses?
We didn't see any of that, the size of the effect compared to but that would be something that would be super important for. I mean, that's basically the axis that you're looking at. Is it more impactful to have the invasive grasses there, or more harmful to have Indaziflam there? So, but I think the Indaziflam effects on annual forbs were often pretty strong, like totally extirpated from these sites. So I would say that is, in most cases, we saw it to be more impactful than, although none of the studies actually tested that, but it's a pretty strong effect.
Good. All righty. Let's see if we have one more question for you. Are native perennials that reproduce more vegetatively than by seed typically less vulnerable to non-target effects of indaziflam?
Yeah, because it specifically targets seed germination. We no study actually looked at this, but just based on kind of our overall information, that yes, they tend to be less vulnerable, just because that is the mechanism which indaziflam targets it. So, and because its effect can be so long in the soil, those are the species that we're like particularly concerned about the seed bank non-target effects long term. So yeah, we're hoping that like future studies will come, do another maybe 7 years of monitoring, do a repeated treatment, and see what those effects are if we start to lose those perennial grass or perennial species that really rely on seed germination for population persistence.